All right, folks. Hello. So now we are moving on to chapter 4, which is trigonometry of right triangles. Now, a right triangle is any triangle with a right angle, right? A 90-degree angle. You see the little square there? That's a right triangle. Now, chapter 4 tends to be, I usually call this the hardest, and that's because there's a couple things we need as a background to be successful in it. And before we jump right into it, we're not going to jump right into the deep end. We're going to practice a couple skills here. Now, you're not going to have some of these pages in your workbook. You're going to see I've input some blank pages that are going to be in here as we go through this video. You are going to need to find some loose leaf. Just straight up, you guys got to get some paper here. You're going to write some extra stuff on top of all of this. So before we jump into it here, we're skipping past this. We're going to go to this here first. So there's a couple things we need. One of the skills that we need, so skill one, is we're going to need to be able to structure and rearrange equations. Well, what does that mean? Great question. So I'm going to give you three equations here. And oh my God, it has an X in it. That's so scary. Don't worry. I promise you'll do okay. 1 over half, 2 over 2, and 2 over 5. Actually, I'm going to minus 7 times 2 is equal to 100. In fact, I'm going to add this one here to do this. Okay, so pause the video, get those down. All right. Now you paused it, you've gotten it down, at least you should have. I want us to kind of think about this here, and we want to break these equations into a couple different things. So for example, if I give you this one here, now this 5, there's a little invisible plus here, right? That's going to come into play a little bit later. But this here, this here is just positive 5, right? This red square. This one here is just negative 3x. And then there's, of course, 21. If I do the same thing over here, 5a, there's a little plus here, is by itself. Make this one red, sure. And then it's negative a half, right? This is minus 1 over 2, minus a half. This little sign on the left comes with it. That's an important thing to kind of note here. So you're just seeing all I'm doing to start out with here is I'm just kind of breaking these equations up. I'm not going to ask you to do this all the time, but this is an important concept that is invisible to math. We always envision that these things, just like how if I tell you that, hey, here's 5. Well, this is 5 over 1 is the same thing as 5, right? There's a little invisible 1 there. If I give you, hey, here's 5 over here, well, there's a little invisible plus sign over there. We don't always think about it, but it's there. So that is in play, going to be important here in this math. So you're going to see I've split these things up here. So if I want us to rearrange these equations where the number or the variable, I'm going to highlight. Where's my highlighter? Highlight yellow. This X here, this A, this C. I want it literally, when I say like rearrange equation, I literally want it to tell me, hey, here's the answer. X is blah, A is 7, C is 100. I want it, the X equals answer. That's what it needs to be. Or the answer is equal to X. Either way works. So we're going to quickly learn how to structure these. And now when we structure stuff, we follow, you've probably seen the word BEDMAS before. In fact, let me just move this over here. You've probably seen this before. If you haven't, it's brackets, it's exponents, it's division, it's multiplication, it's addition, and it's subtraction. Now, we kind of do, we do it in this order. Now, these two, addition and subtraction and division and multiplication, are kind of clumps together, just as an FYI. But this is kind of the order we follow with stuff. If I were, for example, you don't have to write this down, but if I were to give you the equation, I don't know, 3 plus 2, all in brackets, minus 3, 2 minus 1, for example, there's a way to solve this, right? I would have to add up these brackets first. So this is 5, this is 1. Then I have to take this 3 times by what's in here. 3 times 1 is 3, and so on and so forth. There's a way to do it, right? There's an order, a sequence you have to do it in. It's the same for this as well. And I know that if you're really confused, that's okay. This is really hard stuff. I promise it's going to make sense as we go through it. If you are unsure, you can always ask me. It's a lot for sure. So if I wanted to structure and rearrange these, for this first one here, I want it to be, hey, here's the answer. X is equal to, here's the answer. So what do I have to do is, I have to get rid of the stuff attached to X. What's attached to X? Well, there's the negative 3x, which is directly attached to it, but then outside of this green square is this positive 5. So I want to get rid of that first. How do I get rid of positive 5? Well, I take away 5, don't I? So why don't I just take away 5, and then this is gone? Correct. I'm going to take away 5, but whatever I do to one side, I have to do to other. So if I take 5 minus 5, this doesn't exist anymore. So cool. On the left side of my equal sign, it's just negative 3x. But now that's equal to whatever I do to one side, you have to do to the other. Well, again, whatever I do to one side, it must happen to the other. That keeps the equation balanced. So I need to take away 5 from the right side. So it's 21 minus 5 is 16. Again, I took 5 away from 21. So now what I have here is I still have something attached to my x, right? I don't care what negative 3x is equal to. I want x. Here's the answer. X is equal to the answer. So what do I have to do? I need to get rid of the thing that's attached to it, which is the negative 3. Now, what's happening with this? I'm just going to add 3, right? Because it's not take away 3. This is negative 3 times x. It's times something there. So I need to do the opposite of multiplying. Opposite of multiplying is dividing. So I'm going to do that to both sides. I didn't do it up here because I didn't have space, but so you'll see me usually do on both sides here. So I need to divide. Now the opposite of timesing by negative 3 is dividing by negative 3. So I divide both sides by negative 3. These ones cancel out, right? And now I'm just left with x as, oh, cool, here it is. And then it's equal to 16 divided by negative 3 is our answer. You can put this as a decimal if you want. It'd be like 5.33333. I'm going to leave it as that, though. So let's try this one here together. Try and go ahead if you can with it, but give me a second. What do I got to deal with first? Well, I got to get 5a, the block 5a by itself first before I can separate these two, right? So it means I got to get rid of this negative 1/2. So what's the opposite of subtracting by a half? It's adding by a half, right? So I'm going to add both sides by a half. These cancel out, and now I'm just left with 5a. Now there's this little invisible plus here. I'm not going to write that in because mathematicians are lazy, but 2 plus a half is, I could put a couple things here. I could put 2.5. I could put 2.5. I could turn this, 2 is the same thing as 2 over 1, right? Which is the same thing as 4 over 2. 4 over 2 plus 1 over 2 is 5 over 2. Try and do that if you can. It's a nice, easy way to keep things going. Your calculator will do that for you. If you really take your calculator and you go 2 plus a half, it's going to spit it out for you in the different forms, right? This is the very first thing we did, was learn how this change button works. So 5 over 2. Okay? So now I need to get rid of this a. No, there's a little plus a here. So then this is 5 times a, right? There's that little invisible times symbol here. So the opposite of times in by 5 is dividing by 5. So I divide both sides by 5 here. That's gone. And I'm left with a is equal to 5.5. Sorry, 5 halves divided by 5 is 1/2. So my answer here is 1 over half. Again, I could put 0.5, but try and keep it as a fraction. It's going to become handy. Remember how I mentioned earlier, try and keep things in practice if you can. This is that unit. You need to keep stuff as fractions here. Again, everyone was given a calculator that does that work for you. If you're not very good at fractions, you're not too confident with it, I've given you a tool to do it for you. If you still don't know how it works, you need to ask at this point, because now we're at the point where you must be using fractions, or you will be creating errors along the way, and it will make it much harder for yourself. All right, let's try and do this last one here by yourself. Pause the video, try and solve it. 3, 2, 1. Okay, oh, sorry, so this is supposed to be equal to 100. My bad. Put a little equal sign there. All right, so first thing I need to do is I need to get rid of some things. What am I going to get rid of? Is it the blue one or the green one? It's the green one, right? I need to be working through here the same way. So the opposite. So in this case, so the opposite here that times in by 2 is going to be dividing both sides by 2. So I divide both sides by 2. Now, these cancel out, so I don't touch the red. The red's the same. I don't touch the blue's the same. It's just the green that's gone. Is equal to 100 divided by 2 is 50. Next, I need to get rid of the next thing, which is the blue one. So instead of subtracting 7, I plus 7 to both sides. And I'm left with 2c, because these cancel out, is equal to 57. Now what do I have to do? Well, this is 2 times c, right? So now I got to divide both sides by 2. And I'm left with c, which is the answer, that's what I want, is equal to 57 over 2. Or, 36.5, same thing. Try and keep it as a fraction. So I hope that makes a little bit of sense. We'll get more practice as we go into this, but I just want to make sure we have that. The next final skill we need is actually there's a couple more skills. There's 2 more skills. There's also one more skill, which is we need to be able to skill 2, label a triangle. Okay. So I need to be able to label as triangle. So if I give you a triangle here, we did this earlier, but as a reminder, let's say I tell you here, this angle here is 30 degrees. Label it. Well, what do you mean label it? Well, you have a hypotenuse, you have an opposite side, and you have an adjacent side. You might be remembering this at this point. Now, the hypotenuse is always opposite of the right angle, right? This right angle, look, what is it looking at? It's looking at the longest side, which is the hypotenuse. The opposite side is always opposite of the angle you're using. In this case, because I'm giving you this angle of 30 degrees, it's looking at this side, right? This is my opposite. And your adjacent is always what's left over. So you need to be able to label a triangle. Why is this important? Because you're going to be given the thing called, and I want you to write this down, called SOHCAHTOA. What the heck is that? Well, SOHCAHTOA is an easy way to remember 3 different equations. Now, there are 2 things in any grade 12 that are pounded into your head. If you're taking biology, the mitochondria is the powerhouse of the cell. That's number 1. And then if you take trigonometry and math, which is what this is, SOHCAHTOA. Those are the 2 things that is engraved in every person with a grade 12's head. You ask anyone on the street who has a grade 12 about those 2 things, they can tell you. All right. So what the heck are these? Well, this one here, I'm going to start with SO. So SO is an abbreviation. The S stands for sine, and there's a little angle in here, right? Anyone remember what that's called? Starts with a T. It's called theta. This little thing I'm drawing is theta, the angle. So the sine of the angle is equal to O, opposite, divided by H, hypotenuse. I'm going to put hype. It's the hype. Not hippo, hyper, hype. So there's number one. Number two, ka, so ka toa, C-A-H. The C stands for cosine of, again, the angle. I'll draw theta in there, is equal to, the next letter is A. So that means it's adjacent. The next letter is a H, which means it's hypotenuse. I'll put my little angle here, my little theta. And then the next one here is T. You might remember, we've used tan before. So TOA, tangent of the angle of theta, is equal to it's opposite, divided by A, which is adjacent. So if you have these formulas in the top of your head, you have these as long as you remember SOHCAHTOA. You gotta memorize that, okay? Right, literally write it on your arm if you have a bad memory. But you will memorize that, I promise you, because you're gonna be using it for the next 2 weeks. Now, this is where we're going here today. So I'm going to write you the steps to solve here. Steps to solve trigonometry. That's a lot. Trig. Steps to solve trig. Step one, label your triangle. Step two, identify the ratio. Identify the ratio. Identify the ratio. What does that mean? Well, that's kind of a hard one, and I will help you out with that here in just a second. I don't need that here. The next thing I need to do, we'll come back to step two. The next thing we do, step three, is write the formula down. So for example, if in step two, I figured out that, I need to use sine, I need to use so, you would write the formula down. And then you just need to substitute the numbers and solve. Now, step five, I'm going to write step 5A. There's two things. If I want to find the angle of something, of a triangle, I use the inverse. Right? Which is like that tan to the power of, for example, -1 we've used before. Again, I know I'm just writing down the steps. We will make sense of this. You are not supposed to understand what's being written right now. That's fine. And then step 5B, to find a side, I do not use the inverse. You would just use regular old tan. So we're going to make sense of this. I'm going to be referring to this a lot. A lot of this course involves right triangles. Sorry, I know I'm moving around. Now, there's one other thing here that I wanted to kind of include. So, which is, sorry, this is step 3, my bad, or skill 3, solving a triangle. That's what this unit is about. Now, skill 4, if you remember from like the first day or two, we had skipped past the thing called Pythagoras. Good old Pythagoras. Now, Pythagoras, that is the Pythagorean theorem. This is basically saying that, hey, a squared plus b squared, I'll draw the squares, is equal to c squared. A squared plus b squared is equal to c squared. What this is saying is that I can take any two formula, or I can take any two sides of a triangle and find a third side. So I use Pythagoras I use Pythagoras when I have two sides of a triangle and I need to find the third side. And the only other thing you need to know is that C is always the hypotenuse. And again, we will go over this a little bit later. So I use Pythagoras when I'm using two sides to find a side. I use trig whenever angles are involved. End of story. If I need to use an angle or I need to find an angle, I use trig. If I need to use sides to get a third side, I use Pythagoras. So this is your little cheat sheet here for a while. I have just given you a lot of information. You do not need to understand it all at this point. That is okay. We're now going to start going into the actual work here.